if you can't measure an accurate simulation of the chemical reactions that go on in the human body while it is alive, basically, if you can't measure that, which we know that a lot of times you cannot, that it has never been really truly ever been done. No one has ever measured a human's chemistry in the matrix that it is alive, ever. There's never been really a true experiment for this at the quantum level of X-rays and gamma rays and or any other kind of radio waves or of anything of such, except they may have done maybe a local nuclear magnetic resonance imaging, but I highly doubt it. It's probably never been done. So technically, when you say you know how chemistry reacts in the human body, you're lying. You're absolutely a liar. You do not know how medicine reacts in the human body. You're lying. It's never been performed. Don't ever say that you do. But there are some results that you can gather from taking a chemical substance into your body. Like, we eat food and we survive. Or like, you have a bunch of skin infections and you take this chemical, you don't take a shower, you don't do anything, you just take this chemical and the skin infections go away. But what you don't understand is that medicine has multiple areas and targets that it can reach. It doesn't just reach one target, and it depends on the dosage. But like, it can vary how medicine interacts with our cells. And this is an issue. The matrix of our cells and our body parts and our tissues and how everything cycles through our system, and it's one big connected system that is chemically semi-specific. How that all happens, even genetically, it is not known while we're alive. No one knows what we do while we're alive. But they measure things like cells in a petri dish, or a microscope, under a microscope, or they measure molecules with a mass spectrometer, or an X-ray crystallography, or whatever machine that they can use to gather DNA evidence and sequence, molecules in the order that they are received. And then they also simulate chemicals from derived chemicals that are measured by a mass spectrometer. They simulate them with computer simulations and algorithms. So like, it's tough to be accurate with this stuff because we've learned that the human body is quantum physical, very quantum physical. And reactions can be temporary, or they can be permanent, or they can be for however long. We don't know exactly everything that goes on in the cells and how things react quantumly. You really have to study a lot of chemistry and physics, and you're going to discover that there are some things that are unknown about chemistry and physics. And there is no real true God law over all of this stuff. And you have to anticipate some things like energy and vectors and magnitudes and quantities. You have to kind of guess at this stuff. But there is some principles that will allow you to kind of understand medicine. And we have gathered a lot of information about medicine, but as far as being accurate about like maybe the more complex understanding of psychiatry, neurology, different things that we can't measure while it's being conducted as a living being, like and how our even food, we don't even know everything there is to know about our food, or our own biological processes chemically. It's difficult. And then energy, it takes multiple formalities, and everything that we do is particles that interact, whether they're subatomic particles or they're chemicals or polymers or compounds, whatever you want to call them. There's all different kinds of particle interactions, and how that all happens is quantum. It's also sometimes specific, and then it can also hit multiple targets and cause reactions in different ways. So physics is, there is a law to it, and it's all about particle interactions, and it pertains to atoms and particles, and that's the basis of chemistry. So we know that this all comes from geometry. Okay, geometry is math, and it extends out from algebra to calculus, and that's pretty well what life is learning the math and the physics and the chemistry and the biology and particles. Even there may be particles that we don't know exist, maybe even in the sun, the moon, the core of the earth. There could be particles causing things to happen that we are not aware of. Like, ask yourself, how does an electron orbit the nucleus of an atom? It has to communicate and exchange some energy, which is some type of particle that we don't know exists. We've never measured the particles that flow between the nucleus or a proton and an electron. You know, but maybe you might want to study hydrogen, which is what they do at Fermi Labs. You might want to study hydrogen and H2 gas to understand what nuclear physics compared to electrons or magnetic fields, or, you know, what's in a magnetic field? Particles. They say it's light, but it may be more than that. And gravity. Gravity doesn't bend space. Gravity is a particle interaction, most likely. We don't know this all for certain. None of what I'm saying is absolute, but it's probability that gives us the reason to believe this. But we're not in a matrix. This is no kind of matrix. The brain, no real human brain that we know of, no cellular interaction could connect to a machine at the quantum level that we know atoms exist. Based on you'd have to, if you wanted to know if you were even real, and that you weren't in some type of matrix, which could vary of different kinds. Like, basically, you would have to understand and hypothesize mathematics and geometry. And then one good thing that you might want to know is that your very own conscious thought means that you are real, and you have the ability to have free will. Free will, free thought, you know, this all, you know, pertains to reality. So there is a basis for reality. And what we know, and appears to be fact to everyone that we know of in our presence, or anyone that might be famous or whatever, the presence of existence is geometrical. You can't have, in mathematics principles, one dimension is not possible, two dimensions are not possible, but everything really and truly is in 3 dimensions and more than 3 dimensions. So 4 dimensions is not necessarily time travel. 4 dimensions is 3 dimensions with an extra dimension. And what that means is that you don't really make no sense. You don't make any sense when you add 1 dimension to 3 dimensions, because essentially 3 dimensions is a cube and an extra dimension is nothing. It's a cube with space. It's not really time because it's just a cube with space, 4 dimensions. It's not really a space. It's not even a space because space is 3 dimensions plus. Could be any number of dimensions in space. But this is a math principle. It's just geometrical principle. And all things are made of particles, and particles are geometrical objects. They have volume. They move, and they are ultra tiny. They're born of the beginning of the universe, which was probably made of a substance I know as plasmodium. Plasmodium was the beginning of existence. It formed everything. And in some way it probably fractioned into particles. Those particles erupted into a storm that eventually probably caused the Big Bang. And because of the law of atoms and chemistry, because of the laws of energy, plasmodium was the origin. It was unknown really what all happened exactly to the T of a science. What happened in the plasmodium of the origin of the universe. But this is going to be called the video of the theory of it all. Amen.